This one.
Okay, so recap together. Everyone found that paper? I think I threw it at the top. All right, so what have we all done? Okay, so first question talks to us about x, y, r coordinates. So the first thing I'm going to do is I'm going to figure out which quadrant I'm in. Okay, so what do I know? I know sine is negative and tan is positive. So that's the quadrant I'm trying to figure it out. Okay, so do we know where's sine negative? Bottoms, right? Remember that? Sine is the negative on the bottom. Tan is positive in the AT. So I'm in quadrant 3. Okay, some of you, this might be helpful before we even go anywhere. This is always positive, right? It's a radius. Always positive. Positive r. This is what? It'd be a negative because it's an x. And then this side is the y, and it is negative. Does that make sense in those quadrants? Okay. 6 ratios. This represents which letter? So maybe you have your yellow sheet in front of you.
Y and R.
Your y and your r. So this is your y and this is your r. So, and I did that by looking at those things, your y and your r. Okay, so I'm going to put negative 24 on that side. And this side is 25. Can you get me the length of the missing side? You're always going to have 2 out of the 3 sides, right? So what's the length of that side? So are we doing Pythagorean theorem backwards? Okay, if you get a nice number, you can square root it. If you can't square root it, you leave it, right? That's the rules. And for me, it did square root nicely. I'm getting a value of 7. But location, it's a negative 7. Okay, now we're ready to answer the questions. So, tan. So for tan, I need a y over an x. Y over x.
We do for 10 and X.
What's that?
So we do for both.
Sorry, which part am I looking at?
Never mind.
Tan is the y over x.
I thought we were like the SEX. I thought we were doing it for that one.
Oh, I'm not ready for that one. I'll do that one next. Yeah. So I'm going to write this as a negative 24 over negative 7. Okay, I'm not going to dock you wrong, but I would appreciate simplifying that. And the simplifying would be 2 negatives make a positive. Okay? And you also know tangent is positive, right? You know that in that quadrant. Okay, so secant, that's the one answer. Secant ratio. So I need an r divided by an x. So I'm going to write a 25 divided by a negative 7. And again, I'm not going to deduct you points. That's all good. But when I write numbers, I don't usually write the negative on the bottom, but it doesn't matter. It's just a negative value, whatever it would be, right, if you were to make it a decimal. Okay, number 2. A point on the unit circle has this as a y value and it's in quadrant 4. So I'm going to draw my triangle. Okay, so I know that this is the y value. So that's the y side. What else do I know? What does this give me? A point that's on the unit circle. What do you know? 1 is the radius, right? So can you get me that missing side? Is the idea, what is this going to be, positive or negative?
Positive.
Positive. Okay, so I could do this squared, subtract this squared, da da da. Do you like to work with fractions? Probably not, I'm guessing. So what's another thing I could do? Times it by 17 to enlarge it. So I'm going to blow it up way bigger. So this would be 17, negative 15, question mark. Okay, Pythagorean theorem. Ooh, I got another perfect number. I got an 8. Okay, so if the question said, what's the x coordinate? Your answer would be 8 over 17. If I said, what's the x coordinate? Your actual x coordinate is 8 over 17. Because remember, this isn't my actual triangle. My actual triangle is like that. Okay, now we can answer these though. Cosecant. So I'm going to have an r divided by a y. So the r divided by y. That's your answer. Or you could have just moved the negative like that. Yep.
I found the x coordinate first and then did everything. I still got the right answer, but would that be wrong if I did that on a test?
You found the x coordinate first?
Like I just did
You didn't blow it up?
I loaded up after I found the x, so I did
Oh.
1 squared, subtract,
Yeah.
subtraction, squared,
And then you end up with 8 over 17.
yeah.
That's all good.
Okay.
Yeah. And you can do your math like that, but it would be like this. So r is 1 divided by negative 15 over 17. So then that, you just have to do 1 times and flip. And then we get to the same spot.
Yeah.
Yep. So if you're using the original numbers, right, that's what you would have looked like. Oh, yeah. Yeah. Like, did you have it that looked like this? Or did you change it?
I had both and then I thought
Oh,
that one was wrong,
yeah.
so I had to do it.
Yeah. If you did this at the test, I think in my question I might have your answer needs to be simplified. So if you left it like this, you wouldn't be quite simplified. You'd have to just flip and multiply to that. Okay. Does that make sense? This is more simplified than that. Cos, so I need cos. Do we know that one? X over r, right? So that would be 8 over 17. Okay, is this coordinate on the unit circle? Justify your answer. how am I going to prove if it's on the unit circle or not? What does this mean? What's going to happen if it's on the unit circle?
R equals 1.
So I'm trying to figure out, does it equal 1? Okay, so you can work with your fractions, or you could work with an enlargement on this. So if you wanted to work with fractions, does this squared plus this squared, does it equal 1? Okay, do we know how to square this? You square the top, square the bottom. So 64 over 81 plus 25 over 81. So I'm getting 89 over 81. I guess 1 squared, but 1, right? Does it equal 1 squared? Does it? No, that's not 1, right? I would need to see an 81 over 81. Okay, do we like that method? If you wanted to enlarge it, you would times everything by 9, right? And then you're trying to prove, is the radius going to be 9? On that, if you enlarge the whole thing, then you'd be trying to prove that it's 9 instead of 1. So 8 squared plus 5 squared is 89, which is not okay? So you're trying to prove that the radius is 1. Okay, conversions. So convert to degrees. So with our conversions, we always use that we have a pi radian is equivalent to 180 degrees, right? So what's the order here? Are you going to times by pi over 180 or 180 over pi? Those are your options. So 180 over pi. You always divide by what you want to get rid of. You can just go about that if you wanted to cancel the pi's before you're in your calculator. Okay, number 2, find a coterminal angle. So this is the idea. We're either going to try to go up 2 pi or down 2 pi or up 2 pi and another 2 pi, or, you know, we could keep going.
It didn't give you the same.
It did not give you the same.
340.
Did you go negative 11?
Yeah.
Did you put
Right,
pi's?
I mean,
If you were doing it in your calculator, you should use brackets. If you were doing it straight in your calculator, you should do brackets like that. Because if you didn't put this in brackets, it would mess it up.
I think I forgot to put pi into the negative.
Yeah.
Times 2 pi. I forgot to put the pi.
Okay. Okay, so we're going to be making movements of 2 pi, because that's a full circle, and if you move a full circle, you're in the same spot. Okay, can you figure out how to change 2 pi to match your fraction? How are you going to match 2 pi to match this fraction? Did you pick? 26 over 13 pi. So we could either go up that much or down that much, okay? Or we could go 26 and another 26 and another 26. We could keep going that amount, but okay. This is what I'm trying to do. I'm trying to figure out an angle that's in this zone. So do you think it'd be helpful if I went up that much? No, I don't think it's going to be good. It's going to be too big. So let's go down. So what is 9 subtract 26 is basically what you're trying to get. Okay. Now, do you understand this? If I went down another, I'd be at negative 43 pi over 13. Do you understand that this angle is now too low? It's too small. Okay, because the lowest I can go is negative 2 pi, so the lowest number on the top can reach is negative 26. That's too much. I've gone too far now. Okay, this time on 3 we're going to go from degrees to radians. So what am I doing? A times by with your pi's and 180s. You're going to do pi over 180. And remember, you have to go for 3 decimals accurately there. Okay. Number 4, we're going to do the arc length stuff. So you have that formula. Arc length equals the angle times the radius. What do you know about the angle? Is in radians. Important, that angle that you go with is in radians. So what do we have here? We have a radius of 30 and an angle of 144 degrees. What is the arc length? So I'm going to take the angle, I'm going to convert it, and then I'm going to times it by 30. So I'm actually going to do everything in one step though. I'm going to convert and do the formula. So we know how to do the conversion. So this is now going to be the radian angle times 30. So this should all be allowed to go one big type into your calculator. And see if we match, and then it would be to 3 decimal places, right? Matching somebody? Okay, so this time, again, the same formula. A circle has an arc length of 20, so I have the arc length this time, and the radius of 8. What is the angle? Okay, so I'm going to divide by 8. And I get 2.5 radians. is the angle. Okay, this question, I probably wouldn't give you a question like this. It's too easy. What I might do is I might say, what is the central angle in degrees? So now what would you do yet? So if I said in degrees, you're going to take this and you're going to times it by 180 and divide it by pi. Okay, so that's all about those conversions. Please make sure on a test that whatever you get here, leave it on your calculator. Because if you round something here, your answer is going to be off. Okay, so don't round something and then times it. Okay, draw this angle in standard position. So what are you thinking when you see something like that? 7/8 is, to me, close to 8/8 or 1 pi. It's close to 1 pi. Does that make sense? Because in my head I'm like 8/8. It's so close to that. So this is 1 pi. So I think I'm going to draw just short. 7/8 to a full pi. Okay, do you notice how I have an arrow on my direction? You need that on there. If somebody drew me this picture, they would get a half out of 1 point. This person gets a half point. This person gets a full point on their test. Okay? The reason is because I don't know, did you rotate that way? I don't know how you got there. Okay. What do we got? Finding the exact values. Okay, so now this is our unit circle stuff. Okay, can you locate this? Where are you going to land? So for me, I think I'm going to take a full circle off that. And then I get 225 degrees. So this is where I've landed. I went a circle, 225 more, and I landed right here. Okay? So that's on your paper. Okay, now Cosecant. When I'm working with Cosecant, it specifically on the unit circle, Cosecant is the flip of what? Cosecant flips what?
Sin.
Sine. And sine is the y. So I'm going to go find the y, and I'm going to flip it around. That's what you're going to do there. Okay. So here's where I'm looking, 225. Here's the y. So some of you might just write it like that, and I'm fine. And some of you might change it, just the negative sign, whatever. I'm okay. Okay, next. Where are you going to land? Where do you land? Negative 7 pi over 6. So you're going to be rotating downward, right? So 6 over 6, you have to understand what 6 over 6 looks like. 7 over 6. So you went, does that make sense? because this is 6 pi over 6. So 7 over 6 is more than a half circle. Okay, so there's where I land. And what should we find with cos? What is cos connected to? On the unit circle, cos is connected to the x. So what is the x coordinate when you look in that position? So do we understand that we're looking at the 5 pi over 6? So your answer is the negative root 3 over 2. Okay, question C. We have 3 things. We can get them all, and then we'll have to do the math here. So cos of 7 pi over 3. Okay, where do you land here? That's my first idea. Where am I going to land? 7 pi over 3. What do you think? So 3 over 3. A full circle is 6 over 3. So 7 pi over 3. So we're landing there. And we want to get the x value there. So can you figure out the x coordinate? So this is what I'm looking at, right in this spot.
Isn't that like, but this pi is not 7 over 3, like pi over 3.
It's pi over 3 is the angle, because if you went 6 over 3 and then 1 more pi over 3, now I'm at 7 pi over 3. See how I went a full circle, 6 over 3, and then 1 more made 7. Okay, so next I'm going to do 4 pi over 3. That was just on our circle, right? We don't have to do anything magical. 4 pi over 3. So my eyes are here. Okay, cosecant. What's a cosecant on a unit circle? What? And obviously flipping. What are you going to flip? The x or the y? It's the y, right? Okay, so I'm here. This upside down, so 2 over negative root 3. Okay, 17 pi over 6. Okay, so that's going to be a circle and then some. So can you do 6 over 6? Okay, a full circle is 12 over 6. What do you think? The next half circle would be what? 18 over 6? So I shouldn't do that. So from 12, I need to go 5 pi over 6 more. 12 plus 5. So that's where I'm at. What do we know about tan? It would be the y divided by x is what you're going to be doing. Y divided by x. So the y, so 1/2 divided by negative root 3 over 2. Okay. With all of this, can anybody tell me if my final answer is going to be positive or negative? If you were to look at this whole thing, what's your answer going to be?
Positive.
Positive. Okay. Because I have a negative and another negative. I can see 2 negatives in the whole thing, which would end up making positive. So 1/2 times a 2 over negative root 3 times a okay, so do you see what I did here? How do you divide fractions? How do you divide fractions? You flip and multiply, right? Dividing fractions, flip and multiply. Okay, I think that I can cancel a 2 and a 2 from the top and bottom. I can also cancel that 2 with that 2 because it's a top bottom. So the whole top comes out to 1. And what is a root 3 times another root 3 going to make? Just 3. There's our final answer. Okay, and we said the 2 negatives will make a positive, right? That's what we said. Okay. So find a location, figure out the x, the y, the flip of something. Okay, now the last section is your trig equations here. So okay, so this was a question from grade 11. What kind of algebra do you want to use? Do we have one variable or 2 variables? That's your... So we have one variable, so we're going to isolate. So let's subtract 9. Divide by 5. Okay, so this is called a trig value. But when we're working with this, we aren't going to be able to do anything calculator with Cosecant. So I'm going to change Cosecant to sine theta. And then instead of negative 8/5, it's negative 5/8. Okay, that's, if you get there, that's like 1 out of 4 points. So don't stop. Angle time. Where am I going to be? Which 2 quadrants? So the bottom 2 is where sine is negative. Okay, so now we're going to figure out an angle by doing an inverse. Well, first of all, I should say, well, I don't know, this isn't on the unit circle, right? So that's why I'm going to my calculator. We don't type the negative in there. And what mode should I be in? What does my answer tell me I should be in? What does my domain say? Degree mode? Okay, so that's what I'm doing. So I'm getting 38.682.
Both sides, right?
Yeah, both sides. It just is telling me how far off the axis I am. That's what that number is. So that's how far I am away from the axis, which is called your reference angle. And now, one more step. I need those actual final numbers. So, for this one, I'm going to be doing a 180 plus it, because I'm bigger than it. And for the other one, I'm going to do 360 minus that number. Okay?
Can you scale me in 0.667?
I think you need to maybe check your mode. Are you in degree mode?
Oh, it's right.
Yeah, it'll give you a funny answer then. And then you'll have to make sure you put brackets around, like how I had it there. Okay. Number 2, you have 2 different types of variables, so you can't isolate. So what's the next steps? Algebra stuff. What should we do with this? Factor. So I'm going to do 2 brackets because it's a trinomial. So how do you factor? How do you break down the FOIL? So what times what makes 3 sine squared? So 3 sine angle, 1 sine angle. That makes that. Okay, so to make the last, do you understand I need a 1 times a 2? But I have to be careful. Where should I put the 1 and where should I put the 2? Because those 2 things need to make -5. So what should I do? Knowing that one of them is positive and one's negative. I need one that's positive and one that's negative. -2 is going to cause this to be -6 and +1. And what do those make together? -5. Okay? Do you see how I did foiling backwards when I factor, right? Okay, so here the trig value is -1/3. Remember how to do that? Opposite divide. And in this one, the sine angle is 2. Okay, this one, I like this one, because why do I like this one? What do you know about that one over here? There's going to be no solution. I know that sine and cosine cannot go outside of 1. Tangent is not that rule, so please don't do that for tan. I always get people on the test that see tan big, and then they say no solution. Here's just something like if I do that in my calculator, error, okay? Okay, we just did this quadrant stuff. So sine is negative. Okay, what's going to be different for me right now? What does this say about my answer? Now my answer is in radian modes, right? So sine inverse 1 divided by 3. But this time, make sure your calculator is in radian mode, okay? And you'll get a small number, right? .33, I'm just going to go 98. I always keep it on my calculator, so I don't even have to worry about my rounding. But okay, so how do we get a final answer? This is going to be pi plus, right? Because you're bigger than the 180 line, which is in this case bigger than pi. Jenny, I haven't heard from you in a while, so I just hope you're still there. Okay. Good. And then this line, you should do 2 pi minus that amount, right?
So why we're not using negatives? I mean, yeah, negative 160 instead of 2.
I'm using 2 pi because that's like the same as how we used 360 before, right?
Yeah, but is
But
it because it's a dot or what's like?
So what's that?
Is it because it's a dot 398 or why? Like, does it matter if we use 2 pi and 360 or?
Yes, you have to use 2 pi because the whole time we're talking about radians. We can't mix degrees and radians.
Oh, so 360 and the other one is only in degrees then?
Yeah, so when I was working in this question, everything I was working with here was degrees. So 360, 180. Here in this question, everything I'm working with is in radians. So this now is pi and this is 2 pi.
What was the question?
Okay. Did she text you? Did she message you?
I think she's still there.
Okay.
You can write it in brackets.
Okay. So here I'm going to isolate because I have one variable. So I'm going to subtract 9 and I'm going to divide by 5. Okay, so that was a half a point worth of work. Don't stop there. Okay, next is me saying, what quadrants am I in? So cos negative. Cos negative. Okay, this time it says for all general values. So when I see that, what is the mode that I should be in? I'm going to be in radians. Radians is the #1 language. So radian mode. So I'm going to cos inverse that. And I get 1.159. Okay, so this line is pi. So for this one, I'm going to do pi minus that number because it's smaller than pi. And this one, I'm going to do pi plus that number.
That's our answer.
Not yet, I'm not done. Yeah, because it says for all angles. For all. So if I have this as an answer, how do I describe that that could be an answer? Or this could be an answer, right? I can keep going and going and going. So I need plus 2 pi k. K is any integer.
So it would kind of be wrong if you had said the cos of -2 and 5 and then the whole plus 2. Okay.
Yeah, like you'll need a number on that. Okay, I think, do we want to do one more of those? I kind of hit all the areas, or do you want me to do this last one? Okay. It looks a little bit harder to factor. We could try to see if it factors. Do you want to? Does it factor?
Yes.
Okay, so let's go the flow number. Give me the flow number. I'm not going to do this one by hand. There's a lot of those things going on. What's the flow number?
60.
Negative 60. Can I think of any multiples of 60 that are going to make a 7? 4 times 15. 5 times 12. Ooh, there. 5 times 12. If I did a plus minus. Okay. So I'm going to list my F options, I'm going to list my L options, and I'm going to pick which ones I'm going to go with. So I could have gone with tan x and 6 tan x, or I could do 2 tan x with 3 tan x. Does that make sense? That's the only way you can make a 6 tan squared x. Okay, options for 10. 110, 2, 5. Okay, what kinds of partnerships can you make with those pairs? You need a 5 and a 12 to partner together. Do you see some connections? 5 and 12. You see my partnerships? 5 tan x, 6 tan x times 2. Okay. Okay, so I'm going to put a tan x and a 6 tan x in the front. And then what did I partner with that? What did I partner with that? That's what I'm going to try to line up. So I did the 1 tan x with the 5. And I would like that to be a plus 5. And I did the 6 with the 2 to be a negative 12. So tan x equals 2. Tan x equals negative 5 over 6. All right, we're going to have 4 different answers on this question. It's going to be a long one here. 4 different answers. Okay, so this I'm in those 2 quadrants. Okay, it said for all real values, so I'm going to try to be in radian mode on that. So tan inverse okay, so I tanned inverse 2 and I was on radian mode. Okay, I'm going to show you something. You don't have to do it, but it's going to save you something, some writing. Do you understand that I could answer this plus 2 pi k, da da da, and then I could also get this number and do 2 pi k? Or I could shortcut it. Do you understand that if I answer this and then rotate pi, I include that number? This only works with tan because tan is exactly 180 away from each other. Only works with tan because they're across. So if I take this angle and rotate pi, I get to another answer. If I rotate another pi, I'm at another answer. If I keep rotating pi's, all of those angles will be good. They work. You could have answered this number. You could have just done 4.249 plus 2 pi k.
How did you get the 1.107?
You could have answered that as well. What's this number? I did tan inverse 2 in a radian mode. Radian mode. Okay. Can you try this one? So tan is going to be in the opposite quadrants. And see what you can do on your own here. And this one will also work in that pi rotation way.